Hello, good afternoon. Welcome to TI Codes Club for this afternoon, this Tuesday afternoon. This afternoon's session is selecting your coding language. Will you be choosing to use TI Basic or will you be choosing to use Python? Now, to discuss these two different programming languages that are at your disposal, we have our regular panelist and expert, Peter Fox. Good afternoon, Peter.
Afternoon, Brian.
Once again, fantastic to have you on the panel. And of course, we have another expert, a particular expert in the Python coding, and that is Sanjeev Meston. Good afternoon, Sanjeev.
Hi, Brian, and hi, Peter.
Terrific to have you with us. I am now going to transfer the presentation to our first presenter, that is Peter. And Peter, from what I understand, you're going to be predominantly taking us through the TI Basic. So without any further ado, thank you, Peter.
Thank you, Brian. I'm assuming you can see my screen there.
Yes, I can.
Beautiful. All right, so Sanjeev and I are going to demonstrate a combination of the differences and similarities between Basic and Python. I'll be looking at the basic programming, and our Python expert is Sanjeev. And the idea of this session is not so much focusing on the inputs and outputs, the sensors and actuators. It's really on the structure of the language and some of the commands that you can use when you're working with the sensors. So we have two more sessions in this series, and they're the ones that look specifically at the types of sensors and how you connect them and what code you need to do that. And the last one is on actuators. So in other words, things like lights and motors, a way to respond to the input. But in this session, we're focusing specifically on some of the commands you will find useful as you start to connect things. For example, where do you put the data once you've grabbed it? How do you collect multiple samples? Those sorts of things. So the structure for this session, we'll first look at programming tools. So that is things like loop structures. That means you can collect multiple samples from an input, for example. There are different types of loops. We've got 3 different loops that you can use. We're just going to cover 2 of them for time constraints, but I will point you to the 10 minutes of code section on our website where we tackle all 3 types. A for loop, for example, has a defined number of steps. In other words, if you know you're going to collect 10 points of data, then I would use a for loop. A while loop is more for I'll keep on collecting data, or at least analyzing it, until something happens. And the final one, which is just a loop, as its name calls it, and that is you can exit at any point. It's not nice to try and forcibly exit the other ones. It's a bit messy. So loop structures is one of the things that we're going to have a look at. Then different ways to display the data, because when your actual program is running, you generally need to show something on the screen so you know something is going on. That is, you might want to display the temperature or the distance or the humidity or whatever other sensor you're using. And the process is the same regardless of what sensor you're using. And finally, storing it. Sometimes we want to collect data and then use it later on. It might be to graph it or to do some mathematics on it, but certainly the idea of storing data is very important when you're doing these things. So let's have a look at the loop structure for a basic program. What I've got sitting on my desk, obviously, is the innovator, and I've actually connected in an ultrasonic ranger. I've connected that to input port number 1, but what we're doing, as I said, is applicable to pretty much any probe that you want to connect. I think Sanjeev is going to be using a temperature probe, for example. So that's the program that I've got written so far. I called mine basic, so that was obvious to you which program language we're using. And you can see the command at the top says connect ranger 1 to in1. So I've called this little ranger character number 1, and I've connected it into input number 1. That's more of what we're talking about in our next session. The bit that we're focusing on today is this little bit here, the stuff that we want to put in a loop. and that is to read the sensor. You can see the command says read Ranger 1, go and get a measurement and then display it. In this case, I've used a for loop and I'm going through it 20 times, and that's all the program will do. So let's have a look at that in action. I'll see if I can bring up my calculator software. Hopefully we can see all that on the screen right now. So there's the program. Now I can type it, which is great on a keyboard to be able to just type in for like that. But there is another way which is really useful on the handheld. If you hold down the Shift key and just arrow down, you can highlight the information or the instructions, if you like, that you want to repeat. So in this case, I want to repeat these 3 steps. You don't repeat the connection one. You only have to do that at the start. You do it once and then the software remembers what's connected where. But these are the ones we want to repeat. Reading the information, getting it from the innovator, and then displaying it on the calculator. So now I'll press menu and option 4, which is control, and there's the 3 loops you can see are at number 5, number 6 and number 7. So I'm going to choose the first one, and you can see it's kind of bracketed my instructions, which is kind of cool. We need some sort of a variable, a counter, so I'll use I, and we'll do 20 steps. So in other words, we're going to count 20 items, take 20 readings as it were. And then control B is to check the syntax and store it, or control R will do both at once. And if I press enter, I'll just set my little sensor up so it's pointing at something. And you can see there as I move my hand towards and away from it is that I've got a list of numbers. Now it's great that I can scroll back through them, but it's not really easy to go back and use them. If I wanted to use those, right now I'd have to type them all in, and that's what we're going to look at later on. So that's a for loop. That's when we know exactly how many times we want to go through the program, or how many times we want to read a particular sensor. So let's have a look at a different type of loop. So I'm going to delete that one. And Sanjeev is going to show you some of these in Python in just a moment. So I'm going to delete that one. And this time, again, I'm just going to select it. And I'll press menu, control, and select option 5. Oh, sorry, option 6 this time. So it's a while. So I might say something like while D, the distance that I'm reading, is greater than 0.1. Excuse me. The 0.1 is a distance measurement in meters, so that's specific to this sensor. But in general, it'll be some sort of measurement. So if it's temperature that you're measuring, it would be a temperature setting you're checking. Now, there's a warning here. At the moment, my calculator doesn't have a value for D. So if I say while D is bigger than 0.1, as it doesn't have a value for D, that while loop will not be executed. So the first thing I need to do is seed it. Seeding it means giving it a value, giving it some sort of existence. So I'll make D equal to 1. Now, as long as my value is bigger than 1, when the program gets to this step here, it says while D is greater than 0.1, read it. Now, the other warning I'll give specifically to people that are programming, or new to programming rather, is have some sort of an out clause. In other words, either have a second condition that allows you to get out of here. That could be a key press. You can use what's called a get key and say, if the key is an escape key, then jump out of the loop. Or it might be some sort of a counter. So in other words, if the loop's gone through 200 times, stop. Because right now, if my value for D never gets less than 0.1, my loop will run forever, in which case I'll have to break out of that program. And there are ways to break out of it. But I'm confident because I've done this before. Control R is saving it or compiling it and ready to run. And you can see the sensor is reading a distance. I'll move my hand around, and you see it's got a lot more than 20 readings this time, and they're just scrolling off the screen. But as I get my hand closer and closer, you can see once I got it close enough, it stopped the first time a reading went below 0.1. Now that's something else to remember as well. It didn't stop at 0.1 because there was no reading of exactly 0.1. It was less than. So try and avoid distance equals or making it equal to some value, because it might not equal exactly that number. And also remember that your last reading will actually be less than your testing value. So there's a couple of tips. There's 2 loops. One is a while, so it continues until something happens. The other one was a for loop, which is a defined number of times. So I'm going to hand over to Sanjeev, and he will demonstrate basically the same sort of thing, but using Python.
Thanks, Peter.
Thanks, Peter. Yeah, and Sanjeev, that we handed across to you. Yes, I particularly liked that articulation of the 2 different ways of doing that looping. Can we do that in Python as well, Sanjeev?
Yeah, let's see. Okay. So, I'm guessing you're seeing my screen now. So what I may do initially is just talk to you about what Python is and some of the differences between BASIC and Python. And then I'll actually show you very similar coding that Peter has done in TI BASIC. So, Brian, if you can just confirm that you're seeing my PowerPoint in the presentation view.
Yes, Sanjeev, we've got your
that's
Python
great.
on TI slide. Yep.
Yeah, that's great. All right, so when you do control document, you get to add all the applications, and right at the bottom, you will see there is this option to add Python. And obviously, the first time you use it, you'll be creating a new program, or rather every time you want to write a code or a program, you would be selecting the option new. And you need to give your program a name. So I've just given program 1, and then you actually have got insert a field over there which at the moment says blank program, but actually you can select modules, and when I go through my presentation you'll see that there are various options. So I've left it blank. One of the things that I probably want to caution you about is if you're using the computer software, it's better to be in the handheld view rather than the computer view, and a shortcut to the handheld view is Alt Shift and the letter H over there. So a very simple program, and what basically this is demonstrating, I have stored or assigned the letter A value of 5, and likewise I've assigned the letter B a value of 7. So in Python, when you see the equal to symbol, it is actually storing a variable and assigning it a value. And then of course I can say print. Now, in BASIC, the equivalent of print was display. In Python, when you use print, it is actually going to display the output or the result or whatever you want seen on the screen. So print is the equivalent of display. So here in Python, you will see it tells you, the number of lines for the code. And if you put any comments or anything, those are also included in the count. So my code actually is 3 lines, but then I've got 2 comments over there, which are also included in the count. However, when there is an error, it will specifically tell you where the error is. So you can go to that particular line number. So that's one good thing. In Python, it tells you in which line you have the coding error. And to run a program, you would use the shortcut Control R, which is basically the same shortcut as Peter used for BASIC. So for running the program, Control R. Now, the output is displayed on a page called the shell page. So it's not the page that we are using to write the code, but it's a new page it creates. And it's a temporary page. It's there as long as you're running the program. And once you close the program, that information is lost. So there is a shell page. Now, you cannot delete the history in the shell page, but once you exit the shell page, the history is gone. But you can use the tools menu to go and delete the shell page, or you can use the TI system module, which also has an option to clear the history. which we will be demonstrating later on. Now, you will see on my left-hand screen, there are built-in modules, which I have highlighted. So the first one is called the maths module. Then you have the random module. If you want to generate anything random, you would be using the random module. Then there's the plot library. These are all modules which are built in. Then the ones that you probably would be using for your TI codes contest would be the TI Hub and the Rover. And besides that, there are certain other additional modules as well. So I've highlighted the Hub and the Rover modules that will be focusing on. But there are additional modules for complex numbers and for images and so on. So if you see on the right side of my screen, more modules, there's a complex maths module, there's a time module, there's a system module, the draw, and the image. And there is an add-on, which is a separate file, the turtle module. Turtle module is one of the most popular modules. And I think you can get addicted to it if you install that. Now, you can obviously type in the code, but it's always advisable to use the built-in functions. It makes life much easier. You are less likely to make any mistakes or errors. So under built-ins, you can see there are the functions, the controls. So controls is something you'll be using very often. And likewise, number 4 is list. And number 6 is input and output, where the print command also sits. So once you start using Python, you will see the value and the purpose of each of those built-ins. Okay. So there is this option to clear the history on the shell page under tools. Now, in Python, one of the key things is indenting. If you make an error with indenting, then obviously there will be problems in your code. But the good thing about Python is if you follow the built-in commands, it automatically does the indenting for you. So you don't have to worry unless you start typing in things manually. That's when the errors can come in. So I always recommend, especially for beginners, to use the built-ins, which will eliminate all the errors. So I've been through that screen whereby I mentioned if you want to run the program, you just do Control-R. You can always check the syntax, but actually every time you create a program, anyway, when you run it, it tells you if there are any errors. So that's just a quick display of what's under functions, what's under controls, and what is under operators. So as a Python user, you will be using these extensively. And you could be defining functions, you could be running the controls, you could be going into the list operations, or if you look at under functions, I've got all these options to create a loop or create the else conditions, and then it's showing all the operators in the very right screen. Just a bit of things that you could do with the list. You can append items to the list. You can remove items. You can use it for range. You can find the length of the list. That's the dimensions in basic, TI basic, the minimum value, the maximum value. You can do the sum. So a lot of these operations that you see are things that you could do on normal TI inspired, if you're in the systems module or using the CAS features. So a lot of them are also a part of the Python coding. And then if you're working with integers, you can have floats, exact values, you can round, you can work with strings, complex numbers. So that's the type over there I've put. And then of course, in the inputs and outputs, you've got the print, which is something you'll use most often. But then there is the input option, there is the evaluate option, when you're writing a code. And of course, a lot of times you want to format and display the text or information in a certain feature, or you want to control the number of decimal places, you will use the format option. There's I don't want to go into the specifics of each of these, but if you were using the random module, these are some of the options under random module. And then the next display over there is telling you what are the things that you got in the plot library. So since we're not going to look at all these in today's session, I'm going to skip through some of these slides. So there's this draw module as well. Then you have the hub and the rover module where you can have inputs and you can also have outputs. And this is what I'll be demonstrating in my second part of the presentation. Okay. I quickly wanted to go through this screen, which highlights the differences between BASIC and Python. So I'm not saying, that Python is better than BASIC or BASIC is better than Python. Both are equally good. And you have to be, whatever you are comfortable with, use that. And it's not going to disadvantage you if you used BASIC or Python, in your TI codes contest. Both of them give you more or less the same results. It's just that the number of lines of code could be different, or the way you display the information, it could be different, but they are very similar. But Python is becoming very, very popular. There are a lot of Python users, and it's finding extensive use in artificial intelligence, machine learning. So that's a reason I would encourage the use of Python. But at the same time, I learned my Python with TI Basic, when I started learning Python. So having the knowledge of Basic also is very helpful. So some of the differences in Basic, when you're running the for or the while loop, there has to be an end statement. So you have to include end for or end while, whereas in Python, you don't have to include those end statements. And the same applies for the logic sections like if or else if. You don't need the end over here. So in Basic, you need end if, but if you look at Python, you don't need that end if section over there. Python is very much menu driven, as I said. If you kind of follow the menu, everything just pops up for you, whatever you need to do. And in Basic, you use the wait command if you want to pause for half a second, whereas in Python, you would be using sleep. I've already mentioned display print is the equivalent of display in Python. And if you want to raise anything to the power, you have to use the multiplication key or the asterisk twice. And if you want to store something, it's the single equal to sign. And if you are actually making two values equal, then or making a comparison, then you have to use the double equality sign. So those are some of the basic differences. And likewise, if you're using the Innovator Hub and you want to turn the light on, you have to, in Basic, say set light on. Now, those are also built-in commands. So you are not typing that in, they're all built in. But in Python, it's just light on over there. So you don't have to have that set over there. And once again, whether it is Basic or Python, these are all built-in commands. Okay. Yeah, so I basically mentioned that, and at this stage, probably you don't need the last bit. And there's syntax highlighting in Python. There is auto indenting, and of course, there are inline prompts, and it's pretty much menu driven. Now, if there are lists that you have created on your CAS calculator, whether it is on the spreadsheet or data and statistics page, Python actually can talk to that data. So that's one of the upsides of Python. You can talk to any lists or data that is sitting on your calculator in your calculator page or notes page. You can actually access that information. Okay, so let's go and write a program. So the first thing is to add Python, you'll go Control Doc and the letter A. So I'm going to now bring up my calculator and we'll actually write a program there. So I can just. So I'm guessing now you are seeing my. Let's see.
We've got your PowerPoint, Sanjeev.
Yeah,
Yep.
I just want to change screen, and if I click escape.
I might just mention that our participants are invited to join us again same time next week, where we will be looking at sensors and gathering data for the 4th session of Codes Club.
Okay,
and
are you seeing my screen now?
We are on your
calculator screen
now,
Yeah,
and
okay.
you're making that
So,
bigger for us. Thank you. Yes.
yeah, all right. So let's go and add a new program. So I'm going to do Control and Doc, and then go right at the bottom, which is add Python and new. And as I said, I need to give it a program. So I'll just call it test Python and 1. And in the first one, I'm actually going to run a while loop. Now type, I'm saying blank program, but if I just click there, you could select a hub project because we're working with the Innovator Hub, and it will add all the necessary modules that you would require for the hub. And likewise, there is for Rover if you were to select that. However, I'm going to skip that and I'll just leave it as blank. Okay. And what I'm going to show you is how to add or do an import manually. So if you go menu, and now if you go to number 8, which is the hub, and click number 1, and it will say you are importing that module. So I have just imported the hub module over there. Now, the first thing is I want to record the temperature. And I have, in my case, to the Innovator Hub. Now, I can't show that, but like Peter demonstrated, he had connected the Ranger or the ultrasonic Ranger. I've connected a temperature probe, and I have connected it to input 1. So I have to assign a name to this. So I'm going to say T, and then if I'm going to assign, so T is the name that I'm actually giving to this probe, and it's a temperature probe. So when I go in here, I can actually show you how this can be done using the menu. And as I said, that's the proper way of doing it. So you go into the hub and you go add an input device, and I'm doing temperature. And you will see it's pretty much menu driven. So I need to give this variable a name. I've called it T, and I have collected it to port 1. And you can see all the available ports are being displayed here. So I connected it to port 1. And I am actually doing a measure. So I'm going to create another variable over here, and I'll just call it temperature. And let's say this equals. And the moment I type in T and I put a dot, you will see it gives me the option to measure it. So I've assigned a name to this measurement, and I'm calling it temperature. And all I had to do was do T dot because that's what I stored previously. And it says, okay, we think you are going to do, wanting to do a measurement. So it lets me pick up that there. Now I'm going to use a while loop. So let's go to the next line, menu, and under built-ins, you will see controls, and right at number 8, you'll see while. Okay. Now it says there is a Boolean expression. So I'm going to say, let the temperature run this loop until the temperature gets to 25. It exceeds 25 or becomes equal to 25. Stop the loop. So that's what I've got. And there is this colon over there that comes if you use the menu. If you don't use the menu and you type it in, you will miss that colon, and obviously there would be an error. And now if you see block, it's done the indenting automatically. I didn't have to worry about that. So all I'm going to do is just copy that line there because that's what I'm wanting to do in the loop, record the temperature each time. So every time the loop runs, it's going to record the temperature. Now, if it is recording the temperature, I want to display the temperature. So I'm going to use the print command, which is again under built-ins, input and output, number 1, print. Now I can just display the result, but what I'm going to do is I'll say add some string to it, temperature is, and the string you can see actually is being displayed in green. I put some spacing there and I've done comma, and I say, okay, go and display my temperature. That's it. So I've got 7 lines over there. Actually, it's 6 lines, really. So 6 lines of code. And now let's run it. Before I run it, I have to ensure that I have connected my Innovator. I think I have. Okay, so let's run it. Invalid syntax while. Okay, so it's given me an error. And that's what happens when we write that. So what is the error? Temperature is print. That's interesting. Everything looks. Oh, while temperature. Yeah, that's yeah. While temperature is less than equal to 25. That's right. Because I needed to give it the Boolean logic here. So now let's run it. And you can see it runs the temperature. Now, if I go and put my hand on the temperature probe, and the temperature went up to 27 and the loop stopped over there. So that was using the while loop. Yeah, I think somebody was making a comment.
Oh, Sanjeev, it was just me looking at the code. We're all good.
Okay. Yeah. All right. Let's go and add another Python code, so control doc, and this time I'm going to run it with the for loop. So same thing, and I'm going to call it test T and number 2, and still I'm going to go with blank. And what I may do is copy the first 2-3 bits over there because I still need that, just saving time. Okay. I probably can jump here. So let's go and do our for loop. So menu and built-ins and go again under control and for loop. I could just do for index in range start and stop, but I'll do the one with the step. So let's call this as I start at 1, stop at 10, and the step size is kept as 1. Okay. And if I can just cut that from there and put it in the block here. So we are saying temperature is this, and let's go and do the print, which I did over here. So I'm just going to copy the print command. So exactly same. And I need to tab there. So not very different. So in this case, now my code is actually down to 5 lines here. And that's telling us where the input is. So that's the hub import. Then that's going to run the loop. It's going to run 9 times. Now with Python, it actually stops 1 before. You know, the indexing is strange in Python. So I'm going to start with 1 and it will give you 9 outputs rather than 10. And we're going to go in steps of 1. So if you want 11, then 10 results to be displayed, then that needs to be changed to 11. So let's run it now. And it's got all my readings. So temperature here, and there's a small change in the temperature, but it picks up immediately. Now, if I wanted, I could have put over there a wait command, which was basically sleep. If I was to do that, sleep 1 second. Now what it is going to do, it will wait 1 second to record the temperature when I run it. So now you can see there is a wait command, which is actually sleep over here, and it's recording the temperature after every 1 second. And that's it. So that's the bit I wanted to demonstrate today. Next session, I will actually show you how to attach the sensors, and you may have 2 sensors or 3 sensors. We could kind of treat one variable, the sensor variable as the input, the other could be the out, or the dependent variable rather. So independent and dependent, and we can actually go and do a graph. So I could do a graph of brightness of light versus temperature, or with distance or whatever. I'll just demonstrate that in our next session. So that's it from me. Brian, over to you again.
Thanks, Sanjeev. And that's...
Yep, and back to me. Thanks, Brian. We're playing tag team here.
Back to you, is it, Peter?
Yeah, back to me.
Back to you. I did have a couple of things I was going to show, but I'm happy to switch across to you. What I was just going to mention was that on the TI Australia website, the under the pull-down tabs for both teachers and students, there is a section on coding, TI codes, and that will lead you to a page where you can get into 10 minutes of coding. I know that's something that we've talked about before. Yes, Peter, that is the one. And so the first thing that you do, I did mention this in the chat, is you select your coding language, and then you select which technology you're using, and then it will take you through a short course. Don't expect to complete it in 10 minutes. 10 minutes is just the time it takes to get you hooked. and then you're stuck in it. Yes, yeah, so make sure you've got a bit of time ahead of you, because you're going to get addicted to it. Could I just mention, if you do have questions for Sanjeev or Peter or myself, type those into the chat now, please, just on the chat bubble, and I will monitor that. We're just about at our time, Peter.
All right, I'll go super quick. So a couple of things we mentioned earlier on, the idea of display. You will have seen both Sanjeev and I just let the expressions flow straight down the screen. So that's just using the display command. You'll probably find that you'll use display at, and that allows you to just have the value being dumped one over the top of another in one place. And if you get a bit fancy, you can draw text, and that in the basic puts it on a drawing canvas. So I've got the program that we had before, and a really simple change. I'll display at line 1, and I'll use the while loop again. So we'll run that one. And you'll see now that the values are just being dropped straight on the screen. It's not flowing up the screen. So it's actually easier to read. And job done. But we don't know what values have gone beforehand. So you do lose information in that way, but it's much easier to read the current value. So that's display at. I won't go through drawing canvas. You can go through the 10 minutes of code for that. But the other thing that we said we needed to do is look at the option to store data. So in this particular case, if I'm using a while loop, I don't know how many values I'm going to read. So it's a little bit trickier. For this session, let me just change this back to a for. And in fact, I'll put in a request at the start. So request. Now I could get these from the menus. Because I'm using the software, it's just going to be quicker. How many samples? I should probably have a question mark because it is a question. Let's say N, and I don't need the D anymore. Oops. And we'll go from I equals 1 to N, and we'll display, and we need to store it, we said. So now that I know how many samples, and I've got some commands I'll throw up in a minute, I'm going to call it data is assigned equal to some sort of a sequence, and this is my favorite way to do it, and that generates a list. The sequence command is generating a list. There's other ways you can do this. Is generating a list of zeros. And how many zeros? N. So X is, it doesn't have that in the formula. There's my formula. So it's just going to generate N zeros to dump in this list called data. All right. So then if I want to store the values, then I'll say data I. So on the first loop, it'll say data value 1, and I'll make that equal to D. And on the second time through the list, it'll make it data 2. So the second element of the list will hold the next data. That's it. I've now created a way to capture that data. So let's run it. We should, oops, that's because I need to change that N4 or N while to an N4. Now we're good. And we'll take 20 samples. You can see they're still just printing on the screen like that. But now watch what happens. If I do data, I've got all of them. Now, if you wanted to create some sort of a time, and I'm not saying this is in seconds at all, but I'll call it time, and I'll say sequence, and we'll just go X1N, and we'll run it again. Just moving the hand towards the sensor. And now look what happens. If I put a data and statistics application in, I can put time down here and data up there. And there's a graph of the data that I captured. And you can do basically the same with Python. So some commands you'll find useful for that. You'll see dim, that will give you the size of a list. So if I go back here and now I type in dim data, it tells me there's 20 elements, which means you can then add to it. You can increase the length of the list by 1 by increasing its dimension. So there's a nice tool. The sequence command, which I just used, I put in a 0. X was my variable, a start and end, so that generated a list of zeros for me. And augment, so we won't have time today, but augment means you can combine two lists. So you kind of cheat. You create an empty list, so you could call it data just with a set of parentheses. So if I said, let me say stuff is assigned equal to that, then when I type in stuff, it just gives me an empty list. So if I wanted to, I could go stuff or augment. Let's do it. And this is just on the home screen. I'm just going to do it here to show you how it works. Augment stuff. And then I'll add another value, let's say 1. So I've augmented an empty list with a new list which has just 1 value. So now I'm going to put another value in, let's say 10. So you can see what's happening is every time I read another data value, let's say the distance was 20, it's just adding it to the list. So it says get your existing list and create an augment of your previous list, which had stuff in it, and the new value. Don't forget to put the new value in the little curly brackets there, because it says I'm augmenting 2 lists. So the other thing needs to be a list, not a numerical quantity by itself. I think that's just about got it all, Brian. So the only other thing I'd be saying is beware of the length of your lists. If you're using a while loop and all of a sudden it runs for 5 minutes and you have 5,000 values, you're going to fill up the calculator's memory very quickly when you just leave that open. So if you're running a while list, consider putting some sort of a cap on it to block it so it doesn't go to too many values. And I think that's all I've got, Brian, for now.
Great, thank you, Peter, again. And I think it's so easy for us to just get caught up, isn't it, in the coding and overlook the fact that it's still tied in on your TI Inspire. That all of the other application types will still be integrated into that. So I think that's pretty good.
Well, that's right. You can do all the maths on it when you're finished.
Yeah, and of course that's the idea. We've got that there. So
Brian, do you want me to, in half a second, display or demonstrate what Peter has just done?
I'm thinking not, Sanjeev, because we are just on time here. But thank you the same. I'm thinking people will go to the recordings of this to go through what both of you have demonstrated. And of course, there's two avenues for that. One being the TI Australia webpage for the webinars link, and the other one, our YouTube channel. You see the links on your screen now. A reminder, please join us if you can again, same time next week, where Sanjeev and Peter will be showing you some of this coding ties into using some more of the sensors, particularly focusing on gathering data to use in your program. Gentlemen, I'm going to close the session now. I haven't seen any more questions coming in the chat. I shall just check that. You may have noticed my comments in the chat promoting our other webinars, particularly a special event that we have on the 30th of March, where Peter has organised to lure a big fish, an AFL legend, to speak with us about some of the statistics of goal kicking as we now launch finally back into another AFL season with crowds in Melbourne. So that's terrific. But I'll close down this session now. Thank you once again, Peter.
Thanks, Brian.
And thank you once again, Sanjeev.
Thanks, Brian. Thanks, Peter. And thanks to all the attendees here.
And we look forward to hearing from you again next time. All the best, everyone.